In section 7.2, we're going to deal with the converse of the Pythagorean theorem and then two other applications that go with the Pythagorean theorem for classifying triangles. So first thing I'm going to do is I'm going to write the converse of the Pythagorean theorem. So the converse will go if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides comma, then the triangle is a right triangle. So this is Theorem 7.2. I wrote it on the board specifically in this layout because we are just going to end up changing the two things that I have underlined in blue to come up with Theorem 7.3 and 7.4. In your postulates and theorems, for this one, capital A, capital B, capital C, lowercase a, lowercase b, lowercase c. The way I would write it is draw this picture and write if c squared is equal to a squared plus b squared, then it's a right triangle. So that's the abbreviated form. Okay, for Theorem 7.3 and 7.4, the whole reason why I have you memorize it in the way of the Pythagorean theorem is it's going to help you. So make sure you have Theorem 7.2 copied into your postulates and theorems. Pause the video if you don't have it copied yet, and then copy it into your postulates and theorems. Then we'll go into Theorem 7.3. So, only difference between Theorem 7.2 and 7.3 is as follows. So 7.3, if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. Okay, that means all the angles are less than 90 degrees. So if the sum of the squares, if the square of the hypotenuse is less than the sum of the squares of the lengths of the legs, other two sides, then it is an acute triangle. Make sure you take the time and copy this word for word, adding the shortcut equation down so that you have it in your postulates and theorems book. And then we'll go to Theorem 7.4, which all we're going to do is, again, change what I had underlined in blue. Theorem 7.4 states, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is an obtuse triangle. And the shortcut, if c squared is greater than a squared plus b squared, then it is obtuse. Make sure to pause the video, and you need to have Theorem 7, 2, 3, and 4 copied into your notes. And we are going to use these shortcuts to classify triangles based on their side lengths. So the three shortcuts you need to know are if the longest side is greater than the sum of the squares of the other two sides, it's obtuse. If the longest side is less than the sum of the squares of the other two sides, then it's acute. And if the square of the longer side is equal to the sum of the squares of the other two sides, then it is right. And we're going to be using those three facts to solve some applied problems. So I'm going to pause on my end. You need to pause on your end. Make sure you have this information in your notes and postulates and theorems. So the primary group of example problems for the converse of the Pythagorean theorem is first to determine whether or not three different side lengths are able to form a triangle, which is information from a previous chapter. And if they can form a triangle, to determine whether the triangle is an acute triangle, a right triangle, or an obtuse triangle. So as a reminder from previous work, we know that the sum of two sides has to be greater than the third for every possible two-side combination. Okay, so the first question I want to ask for each of these are, can they form a triangle? So I'm going to take the two sides, add them up, and see if they're greater than the third one, and do that for all three combinations. And if that's true, it forms a triangle. If it forms a triangle, then I'm going to go through, after I do all four of these, to determine whether they are right, obtuse, or acute triangles. So 9 plus 12 is 21, check. 12 plus 15 is 27, check. And 9 plus 15 is 24. So this one is a triangle. What I'm going to do here is I'm going to square everything in here so that I can work on this, because I don't know which one's the longest side right now. So 10 squared is 100. 15 squared is 225. 5 root 13 squared would be 5 squared, which is 25, times 13. And if you have 13 quarters, you have 425. No, that's not. Yeah, that's $4.25. Because 12 quarters, nope, 13 quarters would be $3.25. So they are in the right order. So what I need to do is I cannot use them just as pure numbers. I'm going to just take the square roots, put that one in the calculator to get a decimal. So 5 root 13. That's approximately 18. So let's ask ourselves, is 10 plus 15 greater than 18? Yes. 15 plus 18 greater than 10? Yes. 10 plus 18 greater than 15? Yes. So this one is a triangle. Next one. Again, let's see what 6 root 43 is as a decimal. 6 root 43. It's approximately 39.3. 24 plus 39.3 is greater than 30, yes. 69.3 is greater than 24, yes. And 54 is greater than 39.3, yes. So this one is a triangle. And the last one is 35 greater than 36. No. So this one is not a triangle. So I'm not going to answer any more questions with that one. Now what we want to do is we want to set up our c squared and then a squared plus b squared for each of these. And when I set that up, the c is always the longest side. And then I'm going to see what sign goes in between these. So I'm going to write 15 squared, 9 squared, plus 12 squared. 15 squared is 225. 9 squared is 81. 12 squared is 144. And this one would be 225. And what is the relationship between 225 and 225? They are equal. So this one is a right triangle. Next thing I'm going to do is do this again. I'm going to take 5 root 13 squared, compare it to 10 squared plus 15 squared. Well, 5 root 13 we calculated was 325. 100, 225. 325 compared to 325. And they are equal to each other. And because they are equal to each other, then this is a right triangle. Okay, next one, longest side is here. So it's 6 root 43 squared compared to 24 squared plus 30 squared. I'm going to put 6 root 40, so I'm going to take 36 times 43 to get that one, which is 1548. 24 squared, 576, plus 900. Compare 1548 to 1476. 1548 is bigger than 1476, so this one is an obtuse triangle. So the last one there, problem 21, that would have been out of your homework. This is not a triangle. You need to make sure that if you are trying to determine whether it's an obtuse triangle, right triangle, or an acute triangle, first you got to make sure is it a triangle? And in order to do that, we use the triangle inequalities from a previous chapter. So that's it for section 7.2. You will do the classwork for 7.2 in class on Wednesday. And on Thursday, you'll have a quiz that covers 7.1 and 7.2 at the beginning of class before we go over the 7.3 work.